What is up, my mathletes? This is section 3.5, day number 3 of solving quadratic equations by completing the square. So what we're going to do here, the goal is to turn something like this, x squared plus 8x plus minus 3, this kind of function, into this kind of function. Remember, there's lots of value that comes from having a function in this format. You can see where the vertex is. It's going to be at h comma k. You can see the vertical dilation immediately. There's also plenty of information that we're going to be able to get out of standard form as well, but we want to be able to go back and forth between the two. The formula we're going to need is an old formula that we had from before. H is equal to negative b over 2a. It's showing up again. Remember, this is the line of symmetry, formula for finding the line of symmetry and finding h. And we're going to plug h into the function to find out what k is. Let me show you what I mean. First thing you got to do is you got to identify what the a, b, and c values are. There's an unwritten invisible 1 right here, so a is 1, b is 8, c is negative 3. If you plug that into the formula, h is going to equal negative b over 2 times a, and in this case it turns out to be negative 4. You take that negative 4 and you plug it back into the function. You write x squared, no, not x, negative 4. Negative 4 squared plus 8 times x. No, not x, negative 4. So this is negative 4 squared plus 8 times negative 4 minus 3. Calculate all of that out. Remember that negative 4 times itself is a positive number, 16. Then 8 times negative 4 is negative 32 minus 3. That all comes out to negative 19. The k value for this function is negative 19, meaning that if you graphed this parabola and you graphed this parabola, they'd be the same functions. They'd occupy the same space on the graph. And furthermore, you would know that the vertex is at negative 4, comma, negative 19, which can be super helpful information to know at times. Let's do the same thing again. Here, there's a there's an unwritten invisible 1. This is actually, the a value is negative 1, b value is negative 12, c value is negative 9. So, using our formula, we've got negative b over 2a, we've got negative of negative 12, it turns into positive 12, divided by negative 2, we get negative 6. The h value is negative 6. Plug that h value into the function. If the input is negative 6, what's the output? You use the original version right here. Negative 6 squared is positive 36, and then make it negative is negative 36, minus 12 times negative 6, that's going to be positive 72, minus 9. You add all those together and you get 27. So therefore, the k value is 27. You can write it right here. The h value is negative 6, so that's going to be x plus 6 squared. And don't forget to put your a value out front. This is, because here's the formula, a x minus h squared. So the negative 1 comes out here. You can write the 1 or not as you wish, but I didn't. It's right here. This one, let's identify a, b, and c. We got 3, 6, and 5. So a is equal to 3, b is equal to 6, c is equal to 5. The h value is negative 6 over 2 times, negative b over 2 times a. So that's going to be, at the end of the day, it's going to be h is equal to negative 1. Plug that negative 1 back into the function, and you get 3 times negative 1 squared plus 6 times negative 1 plus 5. Negative 1 times itself is positive 1, so it's 3 minus 6 plus 5, which is actually 2. So that's the k value. Here's the h value, x plus 1 coming into play. The k value is 2. And remember, the a value is 3, so that can go right here. I just wanted to take a moment to let you know that for the audio check, my favorite national park is Yosemite in California. Stunning, stunning beauty and amazing natural beauty everywhere. It's really wonderful. If you've ever been there, let me know. If you've got another favorite national park, a U.S. national park you've been to, you let me know about that too. All right. So we're going to write each function in vertex form. Then we're going to find a whole bunch of information about it. So here, we're going to do the same thing we did above. A is equal to 1, b is equal to negative 2, c is equal to negative 5. And so we got h is equal to negative b over 2 times a. That turns out to be a positive 1. You plug 1 into the function as an input, and the output is negative 6, as you can see here. So that means h is 1 here, k is negative 6 here, the a value is 1. You don't really have to write it. So therefore, it has a line of symmetry along the h value with x is equal to 1. You could graph it vertically, and the line x equals 1, and that would be the line of symmetry. Now, not knowing what the graph looks like, you can say that a is greater than 0. You know that since a is greater than 0, it's going to be opening upward. It's going to be a U shape instead of an N shape. So opening upward, it's going to be a minimum, and the vertex, we already know it's in vertex form. It's going to be 1 comma negative 6. 1 comma negative 6 it's in HK form. That's the information we can know without even looking at the graph. Kind of convenient and useful to know at times. Here, a is negative 1, b is 6, c is 1. We're using h is equal to negative b over 2 times a. That's going to turn out to be a positive 3. If 3 is the input, you put it in here and you figure out what the output is. To fix that, because it used to be, I forgot the negative right here. When you plug 3 in, you get 3 squared and then make it negative, plus 6 times 3 plus 1, which is actually 10, not the number you saw from before. And so then, therefore, k is equal to 10. Therefore, if h is 3 and k is 10, the formula is going to look like this, and it's going to be f of x is equal to negative 1 times x minus 3 squared plus 10. Here's the a value, negative 1. Here's the h value, 3. And here's the k value, 10. The line of symmetry is going to be at x equals 3, just along the vertex where h is equal to 3. And since a is less than 0, it's a negative number, so the vertex is actually going to be a maximum, 3 comma 10. It's going to be an N shape. It's going to be opening up downward. It's going to be opening downward and like the shape of an N, not the shape of a U. All right, here y is equal to 2x squared plus 2x plus 3. A is 2, b is 2, c is 3, h is negative b over 2a. And when you do that, it gets to be a negative decimal. That's fine. You can take that negative decimal, put it into the fraction, put it into the function, and then you get negative 0.5 squared. All right, so I just finished proofreading all of that, and so we get here, when you plug in the h value, you get the k value here, and then this is going to be f of x is equal to a times parentheses x minus h, and the minus 0.5 turns into a plus 0.5 squared plus 2.5. The line of symmetry is going to be x is equal to negative 0.5, and a is greater than 0, so the vertex is that, and the minimum, and it is going to be a minimum because the a value is greater than 0. So, yeah, there it is. All right, on the back page, we've got projectile motion formula. It is h of t, the height is the output, the input is time. So that's equal to negative 1/2 g times t squared plus v0 times t plus h0, the initial height, initial velocity, and g, the strength of gravity. Where on Earth, depending on if you're using feet or meters, it's going to be g is equal to 32 or 9.8. For each of these, use the equation and a grapher to report information about the highest and lowest points on the trajectory. Okay, so let me get that right there. Okay, fireworks. A firework at an amusement park celebration is launched from a platform 2 feet off the ground at a velocity of 96 feet per second. All right, so what we want to know, the things that are unknown are the maximum and the minimum heights. What we do know is that the h of 0 is 2 feet, the initial height is 2, the initial velocity is 96 feet per second, and the strength of gravity is 32 feet per second squared. So therefore, we can take our formula here, this, and we can plug in g, v0, and h0 at the very end. That's going to be negative 16, that's 1/2 times 32 is negative 16 t squared. v0 is 96 plus h0, and you can tell me what that is when you get to the Edpuzzle questions. We take our formula, negative v over 2a, that's going to actually give us the time for the maximum. Remember, this is, because it's a firework, and it's a projectile that's being shot up in the air and curving back down again in a parabola. That's a downward-facing parabola, and we can expect that because the a value is going to be negative 16. In fact, if you want to find the input, the t value of the vertex at the very top it's going to be negative b over 2a. That's negative 96 over 2 times a, which is negative 16. Crank all that out in the calculator, you get 3 seconds. And if you take that value of 3 and put it through the function, the h of t function, if the input is 3, then you can calculate that the output is 146 feet. Looking at a graph, you can see that the x-intercept, or the t-intercept, is going to be at 6.021 approximately, and then at a height of 0. Deck design. The Rayburn's current deck is 12 feet by 12 feet. They decide that they would like to expand their deck and maintain its square shape. How much larger will each side need to be for the deck to have an area of 200 square feet? So we don't know is what the side length increase is, and we'll just call that x. It's just starting at 12, and we want it to increase a little bit. How much? Well, the initial, it's starting at 12 feet, and the final area is 200 square feet. And we also have a formula of the area of a square deck is equal to the side squared. So what we can say is the final area is 200. That would be 12 plus the increase is squared is that. So you can undo the exponent with a radical and take the square root of both sides, and you get 14.14. We're going to ignore the negative value because it doesn't make any sense in geometry, in this geometry at least. And so then you can subtract 12 from both sides. Undoing the addition, you get that x, the amount of increase is going to approximately be 2.14 feet. That's just how much they need to increase it by. One more example here. This is from copy and paste from an SAT. This is a released SAT question from the College Board, and you can see here this is in what's actually called vertex form. This is a great form for a parabola if you want to know where it's going to intercept the x-axis. It says in the quadratic equation above, a is a non-zero constant. The graph of the equation in the xy plane is a parabola with vertex c comma d, which of the following is equal to d. It basically wants to know what is the y-coordinate of the vertex. And they're using different letters to confuse you a little bit. C and D, that's kind of unfamiliar. Here's method 1. If you could FOIL, for example, you get y is equal to ax squared. If you FOIL all that out, you get y is equal to ax squared plus 2ax minus 8a. And you might be like, just a little confused about that because this is one of those problems, again, one of those very difficult problems where they give you a letter where you expect a number and then you just have to continue forward with what you normally expect, what you would normally expect to do. So foiling, all of you are great at foiling, but foiling with a letter out in front, that might be a little newer, a little tricky. That's okay. X times x is x squared, and times a is ax squared. And then the outside would be 4x, and then the inside would be minus 2x. So 4x minus 2x is positive 2x, and then times a is 2ax, or a times 2x. And then minus 2 times positive 4 is minus 8, times a is minus 8a. That's really all right, because you can take all that information and put it into the HK form. HK, the formula, negative b over 2a. It gets a little tricky because you have to remember the difference between a and a, like they're both the same kind of a. So this would be negative 2a, which is the b value right here, divided by 2 times a, which is here. The a's actually cancel out, and you calculate it to be negative 1. So the x coordinate, so therefore c is equal to negative 1. If c is equal to negative 1, then you can put it into this function. Negative 1 squared is positive 1. This would be if you're replacing x with negative 1. So this would be a times 1 plus negative 2 times a minus 8a. And it all calculates to minus 9a, which is the right answer. Now you might be tempted to say, oh, I see a minus 8a here. When you first FOIL this out, and you might dive for this trap answer right here, but don't go for it, because that's not what you do. Remember, you can use the negative b over 2a formula, and then plug the number you get, negative 1, into the equation to get the output of negative 1. and to get the output of negative 9a. The second way of doing this, and it's intercept form, like I was saying. Here's a formula: y equals a times x minus p times x minus q, and in this format, if it's already factored, it gives you the x-intercepts immediately, which is often really helpful. If whatever number p, this would be p minus p, or whatever number q, this would be q minus q, and those are the two x-intercepts. So here, if you look at the formula, you can see immediately that the x-intercepts are positive 2 from this factor and negative 4 from this factor. If you put in positive 2 or negative 4, immediately you get a y value of 0, and that's what the x-intercepts are. So you know immediately that the x-intercepts are 2 and negative 4. And if you're a little savvy, you could say, wait a minute, halfway in between the two would be where the vertex is. By symmetry, parabola is symmetric, so halfway in between the two intercepts is where you're going to find the vertex, or at least the line of symmetry. That c value is going to equal 2 plus negative 4. You're going to average them out, add them up and divide by 2, and the midpoint, the x value that's halfway between, is negative 1, which is as we calculated before. You can plug in negative 1 to any format. Doesn't matter, the foiled version, this in standard form, or the intercept form here, and in either case you do get negative 9a, which is right here. So that's that. Thanks for listening. Thanks for playing along, and I'll see you in class.